Hello and welcome. My name is Christoph Pilz. I am affiliated with the Virtual Vehicle Research GmbH, and my focus in my daily work is cooperative, connected, automated mobility. For the InSect project, I designed the vehicleCAPTAIN toolbox. The vehicleCAPTAIN toolbox provides an entry point for early stage research and development in the V2X domain. In this presentation, I will talk about the features of this toolbox. Let's start with a quick introduction into the V2X domain. V2X is short for vehicle to everything. It is used as general term for the communication between vehicles and infrastructure. We also call this form of communication CITS communication. CITS is short for Cooperative Intelligent Transport Systems. To date, there are a handful of physical interfaces that can be used for communication. The final winner is not yet decided. Messages are thereby exchanged via those interfaces depending on the use case. The general point of V2X is to extend the onboard perception that can be achieved with onboard sensors. Exchanged data comprises positional information of traffic participants, notifications of traffic hazards, and many more. For a better understanding of the following slides, I want to introduce you to collective perception and foresight safety as example use cases. Collective perception is the sharing of sensor data between vehicles. As can be seen in the top right, the white vehicle cannot directly detect the pedestrian in the intersection. However, the red vehicle can share this information via V2X. Similarly, at the bottom right, the red vehicle cannot know about the blocked road ahead. However, the blue vehicle can warn about it, which ensures a smoother ride within the red vehicle. Building on top of what we know about V2X, we can dig into the technical perspective. In this slide, you can see the processing chain of V2X. We will start in the top right and go clockwise. First, you will notice the sense plan act cycle of an automated vehicle. This cycle represents the general functionality. Imagine, for example, an automated vehicle senses a pedestrian on the road. It next plans a route around the pedestrian, and this plan is then acted upon as driving commands. Coming back to the use cases, we want to share the sensor data via collective perception. The sensor data is taken from the automated driving stack and put into the ROS gateway of the vehicleCAPTAIN toolbox. The sensor data is thereby encoded into V2X and sent via a physical interface. In case of the vehicleCAPTAIN toolbox, we use the vehicleCAPTAIN development kit. On the other side, we have a similar approach. We receive the data from the physical interface. The data is decoded and put into a format usable by the automated driving stack. The information is then relayed to the planner of the receiving automated vehicle. The vehicleCAPTAIN toolbox assists the explained data exchange with several software components provided as free and open source software. The provided categories are libraries for encoding and decoding, platform software to enable quick setup and communication, ROS2 support for V2X messages as interfaces to physical hardware, and special tools to assist the other packages. The following slides will discuss parts of the toolbox in more detail. The routing core is the most important part from platform perspective. It provides a one-for-all interface for V2X. In other words, one can connect many different vendors and APIs on the one side and simply use one interface on the other side. Within our daily work, we use this platform for parallel sending of data via 802.11p and the mobile network carrier. Looking at the flowchart, one can see the flow of information. At the left side, a message is received via one of the interfaces. This message is then put into a common format by the I/O controller. Next, the internal routing provides the opportunity for implementing lower network layer control. And finally, the data is decoded on the platform or when received via the external CRMQ interface. Sending works exactly the other way around. For other use cases, we provide message libraries. One has to say that many physical interface providers already provide encoder and decoder libraries. However, in research and development, one often has to use pre-standard messages. For these applications, we provide the VCITS library and its generator. The generator's basic design is Docker-based for out-of-the-box usage. As can be seen from the diagram, the script loads the most recent message standards at startup. The user can then select which messages to generate code for. The generated code is then extended with C++ helper functions as well as CMake files for project integration. All in all, this library provides quick entry into the V2X development domain, as it can be easily extended with new message formats. Next, we have the ROS2 support. In our daily business, we heavily rely on the versatile environment that is provided by ROS2. Hence, the ROS2 support has the most active support from our developers. The V2X gateway is the core of our ROS2 V2X stack. The gateway first connects with the server implementation to the vehicleCAPTAIN routing core or any other physical interface. The gateway then internally processes the received V2X messages with message-specific handlers. The processing is in major parts the conversion from ASN1 byte stream to ROS2 type V2X messages. These ROS2 type V2X messages are part of the library collection. The messages are generated from specification source with specialized tools from the tool section. The ROS2 messages are then finally distributed to the automated driving stack. Sending of those V2X messages works exactly the other way around. Finally, I want to show you our development kits. The purpose of our dev kits is to provide an easy entry into the V2X domain. On the left side, you can see our vehicleCAPTAIN Quad Expander development kit. This kit allows us to use 4 different MPCI Express or M.2 interfaces at once. Additionally, one can connect interfaces via Ethernet or USB. The routing core, running on a Raspberry Pi, controls the communication. On the right side, one can see the first generation of the dev kit, as well as the latest. Both provide only one slot for one MPCI-E or M.2 interface. However, the PCB in the newest generation is easily extendable by design. Just jumping back to the left side again, you can see our automated driving demonstrator with the trunk open where we put in one of the vehicleCAPTAIN Quad Expander development kits. It is currently equipped with a V2X interface, a mobile network interface, and a GNSS interface for 1 PPS time synchronization. This last slide concludes my introduction. I hope I was able to provide an interesting overview of V2X and the vehicleCAPTAIN toolbox. If you are interested to start development in any part of the V2X domain, you may find parts of the toolbox useful. If you have any questions towards this video or towards the toolbox, please don't hesitate to contact me.